Hi guys, welcome to CrackGate Online. This is the second video on tractor hydraulics. In the last video, we have covered the requirement of hydraulic system, basic fundamentals, and the basic hydraulic circuit. So here we are going to cover a little bit more. This is something about myself. So in this video, we are going to cover the hydraulic symbols, hydraulic power, and a numerical problem related to hydraulic power. So first, hydraulic symbol. For making any hydraulic circuit, we need the help of hydraulic symbol. So either we have to remember these hydraulic symbols, how the hydraulic symbol of pump looks like, or how the relief valve symbol looks like, or how the actuator looks like. Or there is another option, we have to understand the hydraulic symbol. Why the symbol is like this? So today, uh, in last video, whatever this hydraulic circuit we have gone through, in that hydraulic circuit, there was one reservoir or tank. After that, there was one uh, pump, then one direction control valve, one actuator, and another, and we had one relief valve mainly. So we'll see. This is one symbol of this is the symbol of fixed displacement pump. Why this symbol is like this? So you see any hydraulic symbol, there will be connections. This is one connection, this is another connection. Mainly there will be two connection or flow, because in any hydraulic connection, in any connecting flow or a path, we will connect this hydraulic component. So this is the downside and this is the delivery side. This is the suction side of the pump and this is the delivery side of the pump. And this triangle is resembles uh, this teeth of any gear pump, which is the main, or see, we can say, basic fixed displacement pump. This triangle, you have to remember this triangle. This triangle is the identification of pump. It If it is on the opposite, if this triangle will be the opposite direction, then it will become a motor, hydraulic motor. Then direction control valve. This is one direction control valve. There are n number of symbols of direction control valve, because direction control valve is major control of a hydraulic circuit. So this is a simple direction control valve. You can see these are called positions. This is one position and this box is another position. So and this this is one connection and this one is the another connection. So it is basically two position direction control valve, and you can see at this position these connections are blocked, and at this position these are connected. These both two lines are connected. So we can easily understand that if we take this position here by some actuation, then there will be flow, and at this position there will be no flow will be disconnected in this direction control valve. For better understanding, you see another types of direction control valve, or I'll cover this thing in when I'll make video on direction control valve. There I'll cover these things in details. This is one pressure gauge. This is pump motor, and this flow control valve. Flow control valve is, this is the connection. This is the connection, and this hub circles. Uh, this makes a gallery for this flow. In actual, this will be a orifice. That orifice will control this flow. If at this side or at this side there is no control of this flow, will make one orifice plate or some any other kind of passages or area to control this flow. As we know, area is the basic parameter of a flow. A flow can be controlled by the area. And this one is a adjustable flow control valve, means this area you can control. You can increase or decrease that area to control this flow. This is one check valve. Check valve will allow flow in one direction. That's what this direction of flow is given. And so that means this valve will allow flow in only this direction. In this, if the flow will come in this direction, so it will get blocked. This is a relief valve. Relief valve construction is like that. There will be one piston like this one, and this, and there will be two galleries. This is the input side or upstream side, and this is the downstream side. So as you can see, this arrow, this line is here. That means these both lines are not connected. So, and here is one pressure line. So in this, with this pressure line, the oil will come here. It will create pressure. That uh, pressure will create force, and it will force it on this direction. And on the opposite side, you can see there is one spring. This is a symbol of a spring. This spring will resist this force. So when this relief valve setting will over, relief valve setting means the setting of this spring. So when this force will be more than the force created by this spring, this force due to this oil will push this piston on this direction, and this hydraulic, this line, this gallery will come here, and it will get connected from this upstream side to the downstream side, and finally the flow will happen. So this is main design of any relief valve. So I think now it is a little bit clear, this symbol. Now you don't need to remember this. You can easily identify by seeing this symbol of relief valve, that this one is the relief valve. And this is a symbol of a reservoir. This one is a single acting cylinder. Single acting cylinder means in rectangular box there will be one connection. One end connection means single acting cylinder. If the connection is at both end, and the piston end as well as the rod end, then it will be double acting cylinder. There are few more symbol like filter. Have to remember like this. And There are some hydraulic connection. For better understanding, you can go through your books or internet. Now next is hydraulic power. In any system, power is the product of effort and flow. So in electrical system, you see, can see it is power is the product of voltage and current. In mechanical system, in a rotational device, it is the product of torque and angular velocity. In hydraulic system, this is the product of pressure and flow rate. In mechanical system, linear mechanical system, the power is the product of force and velocity. In all the system, in all the systems, the unit of power will be the same. Now in this picture, it is a simple picture of a hydraulic circuit. Here you see this hydraulic power, a hydraulic pump is getting power from this electrical motor, and electrical motor is actuated by this electrical system. So here electrical power is getting converted in the rotational mechanical power. Then this is getting converted into hydraulic power. Then hydraulic due to this hydraulic system, this actuator is running, and finally this is also converted into mechanical power in terms of force and velocity. So there are three control parameters of hydraulic system. This is one is force and speed, and another one is direction. The force is due to this pressure, the speed of this actuator is due to the flow, and direction is controlled by the direction control valve. Now if the concept of hydraulic power is clear, then we'll go to a numerical problem. We'll solve a numerical problem from GATE 2017. So this is the problem. Here it was asked a hydraulic system comprising of a pump and a single acting cylinder, just like the last picture. Single acting hydraulic cylinder, it lifts 11 kilonewton of load. So this is the pump, this is the single acting. It is not single acting. I can see it is a single acting cylinder because this line is directly connected to the reservoir. So this is a cylinder, and this side it is the load is 11 kilonewton. Now what they said, the pump flow rate is 25 lpm and the overall efficiency is 80%. Overall efficiency means here overall efficiency of the pump, and the cylinder diameter is 80 mm and its efficiency is 90%. So here in this cylinder, this diameter 80 mm and the efficiency is 90%. Efficiency means in the hydraulic cylinder, in between that piston and the casing there will be some leakage. So if the load is more, then leakage will be more. So there will be some losses. So whatever power is getting, it is getting whatever the hydraulic power, it is not actually converted into the mechanical power. There is some losses, so we need to consider that efficiency also. And there is a pressure drop in the hydraulic circuit, that is also 500 kilopascal. So What is the question? The power required to drive the pump in kilowatt will be what? So first we need to see what is what we need to find out, that is the power. Power is the we need to find out power is the product of pressure and flow. Simple. Now pressure, how we can find out pressure? Pressure is simple, force divided the area. We have force 11 kilonewton, and we know the diameter 80 mm. So with this force and the area we can easily find out the pressure. Now there is one trick in any numerical problem. You need to see this units very much carefully. In hydraulic system you need to remember only 2-3 units, then there won't be any mistake. Here this load is kilonewton. The unit of the load is kilonewton. So we can see if the unit of load is in newton and the area in millimeter square, so newton per millimeter square is megapascal. Megapascal is equal to 1000 kilopascal. This is the relation. You need to remember this, otherwise there will be some mistake in the calculation. Okay, and for flow calculation, this relation you need to remember. One is 1 meter cube per minute is equal to 1000 lpm, and 1 lpm is 1000 cc per minute. These are the two relation in a hydraulic circuit, two relations of this flow and pressure in hydraulic circuit. Now we'll see efficiency. There are two efficiencies considered in this. One is the efficiency of this pump, and another one is the efficiency of this motor. Of this actuator. So efficiency is what? It is nothing but the output divided by the input. So as the pump flow rate is 25 lpm, so and the overall efficiency is 80%. So the input flow of this pump will be 25 lpm divided by 0.8. That means 80% is 25 lpm. Then what will be the 100%? So 100% is the input what it has taken from the hydraulic system. So the input flow is 31.25 lpm. It comes like this. And when I'm talking about this pressure also, we have to calculate the pressure from this force and the area, and its efficiency is 90%. So what will be the pressure there? We need to divide it by 0.9, then we'll get the actual pressure on this. And there is some pressure drop. What is pressure drop? See, pressure drop means in this line, in between this pump and the cylinder, there will be either pipe connection, or there will be some passages. So due to these passages of pipe connections, and due to the bend of this pipe, there will be some losses, that is called pressure drop. So that losses we can calculate in terms of pressure, so it is called pressure drop. So this pressure drop also we need to add with this uh, pressure, with the system pressure, because this pressure also getting generated by this pump. So if we add this pressure with this pressure at this cylinder, will get the total pressure here, and the total power will be the simple the multiplication of this to pressure and the flow. So I think this is clear. So this is up to this one is for today. So in the next video we'll cover little bit more details on pump and other components. Okay, thank you. Please subscribe, like and share. Bye bye.